Alright, so we're just going to practice what we learned, but we need a couple of steps. Step 1, who's the daddy? Step 1, who's the daddy? Step 2, graph the daddy. Graph the daddy, step 2. Step 3, starting at each point. So listening check, underline starting at. Starting at each point, perform the transformation. Starting at each point, perform the transformation. So left to right. So starting from the left, going to the right, perform the transformation. Go ahead and put it in the title too. It's going to be function rule transformations. Function rules transformations. So those are just the 3 steps that you need to do each one. So number 1. Graph the daddy. Well, who's the daddy? It's an x squared function. So you got to graph what that x squared function looks like. So it starts at 0, 0, then 1 squared is 1, 2 squared is 4, 3 squared is 9, negative 1 squared is 1, negative 2 squared is 4, negative 3 squared is 9. So just like before, that's why we're going a little bit quicker. Now I've graphed my daddy. Starting at each point, perform the transformation. So we need to know how this graph is going to transform. So we've got negative 2 inside the house and we've got positive 4 outside the house. Okay, start with the easy one. Positive 4, that's outside the house, that's going up. And that's negative 2 is inside the house. Remember, inside is always x and opposite. So it's going, you think it's going left, but it's really going right. Then count each point. 4 up and 2 right. 4 up and 2 right. 4 up, that one I can't do. 4 up and 2 right. 4 up each point and 2 right. 4 up and 2 right. And now once you've done each point, just go ahead and graph your new function, and that is that function. Then let's look at domain and range. Remember from before, domain is x, range is y, so the x values goes from negative infinity to negative infinity. Y values, you see it starts at 4, including 4, so you put a box with 4, goes to infinity. Alright, number 2, parent, who's the daddy? X cubed. So go ahead and graph the daddy. So 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, negative 1 cubed is negative 1, negative 2 cubed is negative 8. And then just go ahead and draw it. So this is what it looks like. This is not actually one of the ones we've done, but it is an important one. Alright, then once you've done that, let's figure out what the transformation is. Okay, let's start with that reflection outside. Remember, if it's outside, you flip and you think it's outside, you think it's y, but it's really x. And then negative 3, what's that going to do? That's going to move right 3, and negative 1 outside is going to move down 1. So this is what I'm going to do to each point. Let me start with the flip first because that's easy. What you're going to do is take each point past the x-axis. Take each point past the x-axis the same amount. So if it's at 10, it goes to 10. If it's at 8, it goes to 8 on the other side. Alright, then we're going to take each of those points and we're going to move them right 3 and down 1. Right 3, down 1. Right 3 and down 1. Right 3 and down 1. Right 3, down 1. Right 3, down 1. Notice I just used a different color so I could see what it is. Then join my new line. And that's what it looks like. So it's flipped across the x-axis and then it's moved right 3, down 1. Let's take a look at domain and range. Again, on the range, it goes on forever in both directions, negative infinity to infinity. On the domain, x-wise, it also goes on forever, negative infinity to infinity. That's it. Number 3, who's the daddy? Square root. So we haven't got a chance to practice this on Excel. That's why we're practicing it now. Square root is the daddy. Then look at what happens to it. So we're going to go ahead and graph it. Pick the squared function. So like 4. Square root of 4 is 2. Square root of 9 is 3, and so forth. Alright, and again, if you want a review on that, just watch the whole video. Alright, so that's the daddy. Then we're going to do each thing. Plus 1 inside is left 1. Plus 4 outside is up 4. Okay, that's what you're going to do. Each point, left 1, up 4. Left 1, up 4. Left 1, up 4. And then just go ahead and join the dots. And that's your new function. And that's really all transformations is. Over and over and over again. Do you know the rules? Domain. Domain, it starts, you see it starts at negative 1. So including negative 1 is a bracket and goes on forever. On the y, it starts at 4 with the bracket because it includes 4 and goes on forever. That's it. Alright, number 5. Who's the daddy? So x squared is the daddy, so you go ahead and draw x squared, and again you could just do 0, 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and so forth. And there's your daddy again, or you could just copy from the one we just did. And then what is the transformation? So starting with that negative outside. Outside is a flip across the, you think it's y, but it's really opposite, so it's over x. So take each point on the opposite side of the x. Each point is directly down on the opposite side of the x. Basically, you're just flipping it upside down. Alright, don't join it yet. Now what you're going to do with each one of those points is plus 5 is left 5 and minus 1 is down 1. So you're going to take left 5 and down 1. Each point. Left 5 and down 1. Left 5 and down 1. And you can't really see because I've taped it. Left 5 and down 1. Left 5 and down 1. Every single point. Left 5 and down 1. Left 5 and down 1. Once you've moved every single point, you can go ahead now and make your little function. You can see I have a little tape here, that's why it's a little harder to take. And this is what it looks like. So domain, all the x values, so you can see it goes on forever in both directions. Range y starts at -1 and goes on forever. So including -1 with a bracket, goes on forever to negative infinity. That's pretty much it. Number 8, who's my daddy? Oh, look at this, it's a cubed function. Okay, so cube is my daddy, x cubed. And I just need to draw it. So pick numbers. 0 cubed is 0. 1 cubed, 1 times 1 times 1 is 1. 2 cubed is 8. 3 cubed is not going to be on the graph. -1 cubed, -1. -2 cubed is -8. So again, that's what it looks like, or you can copy it off the one we just did. And then we're going to take each point and we're going to move left 3 because it's inside the house, the opposite, and up 4 because it's outside the house, regular. I don't know why I wrote 5, but it's supposed to be 3. So left 3. So don't look this, just do it on yours. Left 3 and up 4. Left 3 and up 4. Each point left 3 and up 4. So I'm doing mine 5, so which is wrong, but I'm going to correct it right after I finish. So you're just doing left 3, up 4. Each point left 3, up 4. Left 3, up 4. Left 3, up 4. Left 3, up 4. Are you getting tired of me saying it? I hope you're not copying down what I'm doing, but you're copying down what I'm saying. This is how I check your listening. Left 3, up 4. Each point left 3, up 4. This is a listening check. Shade in -9 on this graph on the x-axis. Shade in -9 on the x-axis graph. So you see, I'm going to go ahead and correct it right now, which means if I went 5 over, I did too much. Too many. So I'm just going to move it over 2. Each point over 2. And that should be the one that you have graphed. So again, it was left 3 and up 4. So it should be the one in green, not the one in blue. Should be the one in green and not the one in blue. This is a listening check. Put a box around x cubed is dad. Alright, looking at domain and range. Again, domain is x, range is y. Domain looks like it's everything. So -infinity to infinity. Range looks like it's everything. -infinity to infinity. That's pretty much it. Alright, last one. Square root is the function, so square root is the daddy. And what are we doing to this? So go ahead and plot it. Again, I pick numbers. I can take the square root off, like 4 is 2, square root of 9 is 3, or you could just copy from the one we did before. Alright, so we're going to flip this. It's outside, so you think y, but it's really flip over the x-axis. So take every point and flip it over the x-axis. So you just need to count how many boxes above the x-axis is and take it on the other side. So that's what it is. And now we're going to do -3 is going to be right 3 minus 6 is going to be down 6. So we're going to move every point right 3 and down 6. Every point right 3 and down 6. Remember, it's the blue one, not the original one now. Right 3 and down 6. Right 3 and down 6. Every single point. Right 3 and down 6. So make an estimation on that last one. Just because you're going to need to have a rough idea so you can see where it is. This is a listening check. Put a box around the number 9. Put a box around the number 9. And so it kind of looks like this. So it looks flipped over and moved. Domain, again, x starts at 3, including 3, so bracket goes on forever to the infinity side. The range starts at -6, including -6, going on forever to -infinity all the way down. And that's it, guys.